They're all reasonably easy to pick up. I had some trouble with a few of them, but for the most part, you shouldn't have any trouble getting what you need. The first thing I'm going to be using, probably the largest thing, is this ceramic bowl, pot, vessel thing. Daniel would have actually used a copper vessel, not unlike that, but made entirely of copper. Ceramic will work just as well. It's a glazed ceramic, so there's no big worry there. But it's best to use glass, plastic, but preferably glass. Going inside that, and what will actually be holding the zinc sulfate, is this contraption here, which I actually had to make rather. Daniel described what he used in the vessel, the larger copper vessel, as a earthenware jar. And basically the point of using an earthenware jar is that it's free, or it leaves room, if unglazed, leaves room for ions to pass through from sulfate to sulfate. However, in this case, a paper tube will do just as well. The problem, of course, is that you somehow have to seal off the bottom so that the sulfates don't mix while they're in the vessel. I've read that you can do plaster of Paris. I didn't have that on hand, but what I did have is paraffin wax, which is used for a number of different things, often for sealing jars of jam and that sort of thing. So all I did was melt some paraffin wax, poured it in a bowl, and then stood the toilet paper roll upright in it. And you can see that it actually completely sealed it off so that nothing is going to get in there, and it has a fair bit of weight, so it'll sink right to the bottom of the vessel. For the copper sulfate, I learned that you can get a product at pet stores called Copper Safe, which is actually used to treat fish parasites in fish tanks. It's called Copper Safe, and it's about $8 or so, and that's just straight up copper sulfate, so that's what I'll be using for that. As far as the copper electrode goes, I mean, anything copper will work. I picked up just an elbow from Canadian Tire for copper plumbing for about 96 cents. As far as the zinc side of things go, zinc sulfate is preferable, so I have, of course, a jar of zinc sulfate here obtained through the Dalhousie Chemistry Department, kindly provided to me. So that'll obviously have to be mixed with water, and that's what I'll use for the zinc sulfate. And for the zinc electrode, a zinc-coated screw. Now, to actually hook up to a light bulb and a multimeter, I will be using jumper cables. I only needed about 4, but I got forced into buying 10 from Radio Shack, but that's okay, they only cost about $6. And finally, I have in here a very little light bulb. I'm sure things much weaker than this battery will be able to light it up, but it's kind of nice to see something actually get lit up by your hard work and experimentation. So that's what I'll be using. Other than that, I'll be using a multimeter just to read the output current from this battery. I don't have it on me right now, but you know what it looks like. So here's the currently finished product. The Daniell Cell battery, a very crude imitation, but should work just the same. I actually scrapped the original idea I had for the main vessel, the ceramic pot, in favor of something that's taller and narrower. My fear was that I didn't have a whole lot of sulfate. As you can see, the bottle's pretty small, and I had to fill a fairly big space. In retrospect, it was a really bad idea to even think about using something this big. It should have been just a very narrow vessel. But I didn't have a whole lot of chance to do that. So I scrapped it in favor of this. So you can see the copper sulfate all at the bottom here, the blue. I actually mixed it with water, which, according to Daniel, is all right. He said a strong solution, so there's, I mean, a lot more of this stuff than there is water. But I fear that I should have done it differently. And of course, you can see the paper tube in there, which I'm actually starting to worry about, because you can see the zinc sulfate is kind of starting to seep through on the seams, which could be ruining some of this experiment. The yellow cable, of course, is attached to my zinc-coated nail, which is inside the tube in the zinc sulfate, and the red cable is attached to my piece of copper plumbing, which is suspended in the zinc sulfate. And you can kind of see the base of wax inside the vessel there on the bottom of my tube. Both of the cables actually come out and connect to my little light bulb, and as you can probably see, it's not lit up, which is disappointing, but I'm going to give it some time, and I'm also going to hook it up to the multimeter and see what we get. The lamp I bought is actually 1.5 volts, so if this thing's putting out 1.49 volts, it's possible that it's just shy of powering it. I might have to leave it a bit longer, but I guess we'll see once the multimeter comes in. We're going to hook it up and see what we get. The light bulb never lit up, but maybe we'll get some alright results with the multimeter. Here's my brand new multimeter. We'll set it to volt over 20. And it looks like we are getting between 74 and 0.74 and 0.75 of a volt, which isn't very much. You can see too, if I lift the galvanized screw out of the water, it goes right down to 0. So we are getting a current. It's not that much. We've even gotten more out of a couple coins in Coca-Cola and Class, which really is kind of disappointing. I hoped it would be more. But that's the way it goes, I guess. So I just finished up a few little tests here with the other things that I said I was going to try out in the vessel, and surprisingly, what I found is that the closest I came to recreating the 0.74, 0.75 that I got with the galvanized screw was actually with I get too much water on my hands. A little block of staples. They actually got it up to about 0.74, or 0.71 I should say, which was pretty impressive. The finishing nail only got about 0.11 of a volt, and of course some of the coated screws didn't even really get anything. There was a large impedance there. Now one thing I have noticed after having my original screw immersed in the zinc sulfate for probably 2-3 hours or so, is that it's changed color. I don't know if you'll be able to see this, but you can see up here it's kind of nice and shiny, and that's how it was. And it's actually gotten significantly blacker, darker, and overall just more sinister looking the further down the screw you go, which I found really interesting. But it seems that that this here, the zinc-coated screw, seems to work the best, but it's still not enough to light my little light bulb. So I've kind of been looking at the design of it, of what I made, and there's a few things I've kind of come to the conclusion on as to why I might have had such a poor output of electricity from it. I think I should have had a more concentrated solution of copper sulfate. I did have to mix it with water because I didn't purchase enough copper sulfate. Probably would have been more beneficial to actually get powdered copper sulfate as opposed to liquid, despite the fact that it was real copper sulfate that I purchased. It was still a solution because it was mixed with water. So maybe next time actually find copper sulfate in a powder form. And the other thing as well is that having left it this long, I think there's a possibility that there is a bit of mixing between the two solutions, or going through the paper tube, just because it is starting to kind of seep through, because it's just cardboard. One interesting thing I did find though is that I took out the copper tube that I was using, and it does look a lot different than it did before. I doubt you'll be able to see it, but you can kind of see how on this end it's really shiny, and it has this funny sort of copper coating over it on this side. But that's interesting because that's actually what John Daniell noticed when he first made his battery. Normally there's a deposit of hydrogen bubbles on this electrode, which really impedes the flow of electricity. What he noticed was that using a copper vessel, it actually left that sort of exactly that coating inside the copper vessel that he was using, and he discovered that it's actually that having it deposited on something else is what stops the buildup of hydrogen bubbles. So that is quite interesting.